All right, now we're going to look at the problems that involve synthetic division. And so looking at number 7 right here, it says when the polynomial f of x equals 3x cubed minus 22x squared plus 37x minus 10 is graphed on a standard coordinate plane, 1, 0 can be seen at x equals 5. Use this fact that one of the zeros is known to factor f of x by using synthetic division, and then find all the zeros of f of x. So what they're telling us is that on the graph, if you were to look at it, it has an x-intercept at 5, which means if you plug in 5, it's going to cause this function to equal 0. And so we use that fact to help us with synthetic division to basically factor this. So what we're going to do is we make our little rectangle and we put those coefficients here. So we start with, let me clean that up. We'll start with 3, and then negative 22, 37, and then negative 10. And so I know that 5 is going to work, and I don't want to change that sign. You just use 5. Now, on the other hand, if it would have told you that one of the factors is x, minus 5 or whatever, then yeah, then you have to change, you set that equal to 0 and solve. But look at it. It's already set, it already has the equal sign, so we already know that we're going to use 5, okay? So just be aware of that. So here we go. We drop the first one and then multiply, add, multiply again, and then add, multiply, and I get 10. So that's going to add up to 0. So yes, 5 is going to be one of my solutions. So I know now as a factor, once again, that would actually be written as x minus 5, right? And so what I have left here, I have 3x squared minus 7x plus 2. And then just kind of really hammer this home, the 5, which is the factor x minus 5, so x minus 5, this right here, this is equivalent to this right here. So we've basically, essentially, we've factored that polynomial. And like I said, they actually told us that 5 would work. And so as a factor, that would be x minus 5. So what I have left to do is factor this. And so you can do guess and check, which is fine to factor it. I showed a method in class, which is a little bit more of a process. And so if you want to use guess and check, there's nothing wrong with that. But over here on the side of my paper, I'm going to go ahead and use that method that I taught in class at the beginning of the semester. And so the way that works is you just multiply the leading coefficient by the constant and just put that number off to the side, and then grab the number from the middle right here, which is negative 7. So we grab that. And then what we look for is we're trying to find a combination where when I multiply two numbers together, we'll just call them A and B. I could call them something else, but we'll call them A and B. So two numbers that multiply to give me that 6, but the same two numbers, when I add them together, will give me a negative 7. So it's kind of like a game here, and if you need to, just play around with it in your calculator. But they multiply to give me a positive, but they add and give me a negative. So what I know is they both have to be a negative, because a negative times a negative would give me a positive, and then two negatives added together would add up to a negative. So it's going to be negative 6 and negative 1. So if you multiply those together, it's 6. If you add them together, it's negative 7. So now what I have to do is I'm going to manipulate this by basically changing this out. I'm going to take this 7 minus 7x and replace it with a minus 6x and a minus 1x. And it does not matter which one goes first. It does not matter. So we keep the 3x squared. That doesn't go anywhere. And then it doesn't matter which one goes first. So I'll put minus 6x and then minus 1x. You can put a 1 in front if you want, but you don't have to. And then we still have that plus 2. Then from here, you do factor by grouping. So on the first set, I can pull out a 3x, and that will leave me with x minus 2. And on the second set, I have the opposite of what I need. I have negative x plus 2. So I'm going to pull out a negative 1, which causes a sign change here. So this will become positive x minus 2. And if you're unsure, you can always multiply it back inside and you'll see that it's equivalent to the step before it. but we do want to go ahead and finish what we're doing here. So the next step would be to factor out the uh, x minus 2. So I'm going to factor x minus 2 out, and then what's left behind is the 3x, and the minus 1 is going to create my other factor. And so that's what this is going to split into. So let's see, x minus 2 and 3x minus 1, and then don't forget about my other factor that we already have, x minus 5 equals 0. So that's my answer to the first part up here. So I need to put these factors on here. And so the order that you list them doesn't really matter. So now I have x minus 5 first, and then I have x minus 2, and then I have 3x minus 1. It doesn't matter because multiplication, the order that you multiply does not matter. So the order that I list my factors, not a big deal. You can list them in any order you want. Then here, now we want all the zeros. So basically all the solutions that will make this equation equal 0. Well, this one right here would be, oops, not negative, it would be positive 2, right? Because if you plugged in 2, 2 minus 2 is 0. The one in the middle is a little bit more complicated, so I'm going to go ahead and set that equal to 0. And so I need to solve this. So let's see, we'll add 1 to both sides. So then we're left with 3x equals 1. And then we'll divide by 3 on both sides, and we'll be left with x equals 1/3. So that's going to be another one of my solutions. And then the last one was actually given to us, right? 5, because 5 minus 5 is 0. So I need to list those up here. So 2, 1/3, and 5. Okay? And so, once again, the order that I list them isn't really important. Sometimes people like to put them in numerical order, but it doesn't really matter in this case. Okay, let's look at our other synthetic division problem. So right here, this time we're not going to be given one of the solutions. So on the previous example, we were given one of the solutions, and that was very helpful. Here, we're not going to be given a solution, so we have to do this rational zero theorem, where we're going to list all these possible solutions that may or may not work. And then we start trying them. And then once we find one that works, then it's going to be pretty similar to the one we saw on the previous slide. So the first thing you have to do is you have to list all your possible solutions. And the way we can do that is you have to list all the factors of -6 in your numerator spot divided by all the possible factors of 5 in your denominator spot. So essentially, you're looking for numbers that divide evenly into those numbers. So in the numerator, numbers that divide evenly into -6 would be positive and -1, positive and -2, positive and -3, and positive and -6. All those numbers would divide evenly into that -6. Then in the denominator spot, numbers that divide evenly into 5 would just be positive and -1 and positive and -5. So then now what I have to do is look at all the different combinations that are possible. So the first combination I'm going to look at is dividing them all by positive and -1. And when I do that, I just get a repeat of all these values that are in my numerator spot. So I'm going to get everything repeated again. So positive -1, 2, 3, and 6. Then I am going to divide them all by positive and -5. And so I have to look at those combinations. So I'll get 1 over 5, 2 over 5, 3 over 5, and 6 over 5. And I have to have the plus minus with them. I have to look at it both as being positive and the possibility of it being negative. Now, these fractions, some of them might work, but those wouldn't be the first ones I'd like to try, because that would be probably pretty messy. So I'm going to start with 1 and -1 and so on. And once I find 1, I should be able to use factoring methods to find the others. So let's see. Give myself a little bit more room. So now we're going to set up the synthetic division. So we make that little rectangle here. And let's see. So we're going to have 5, -8, -19, and -6. And so I'm just going to go in order. So I'm going to start with 1. So we drop the 5. 5 times 1 is 5. 5 plus -8 is -3. -3 times 1 is -3. Add that together, that's -22. I can already see this is not looking good. I get -28. So that's 1 does not work. So let's try another one. So I make my little rectangle box. And then we're going to try -1. So we drop the 5. 5 times -1 is -5. That adds up to give us -13. We multiply that together. That's +13. That adds up to -6. Ooh, this is looking good. And then let's see, -1 times -6 is +6. That adds up to 0 right there. And so, yes, I found a solution. So I know that -1 is going to work. So what I'm left with is 5x squared minus 13x minus 6. And what we're trying to figure out is what would make that equal 0. And if you really wanted to, and you could continue the synthetic division process and try 2 and then -2 and so on. And hopefully you'd eventually get there. But the problem might be that our solutions might not be rational. I might have to do the quadratic formula. I don't think that'll be the case on this example, but it is possible that that does happen. This should be factorable. So let's see. I'm going to, once again, on the side of my paper, I'm going to go over that process again. So we're going to multiply the leading coefficient by the constant right here, which is -30. And then we're looking for two numbers that will multiply to give me -30, but when I add them together, they will add to give me -13. So they multiply to give me a negative. What we know about that is one will have to be positive and one will have to be negative, right? So I'm going to have one positive and one negative number that multiply to give me -30. Then those two numbers have to add to give me -13. So just take a moment to think about that, maybe even pause the video and see if you can come up with those. So even if you're having a hard time, you can just start with like -30 times 1. But the problem is that doesn't add up to -13. Okay. Then you could try -15 times 2. Oh, bingo. I already hit it really quickly. Because when I multiply that, it's -30. And when I add that, it's -13. So I already found it pretty quickly. So what we'll do now, once again, is we're going to replace that -13x. So we still have the 5x squared, and then we're going to put the -15x, and then we'll put plus 2x. That's what's replacing this. It's equivalent, right? If you add those together, it's still -13x, right? So we're just kind of manipulating this to help us. And then now we're going to do our factor by grouping. So on the first set, let's see, we'll pull out a 5x, and that will leave us with x minus 3. And on the second one, we'll pull out a 2, and that will leave us with x minus 3 also, which that's exactly what we want. And so then now we'll go ahead and factor out that x minus 3. And then I'm left with the 5x plus 2. So that's what I get here. So let's see, x minus 3, 5x plus 2. So the first one's pretty easy to see that it's 3, because if you plug in 3, that will make this go to 0. On the other one, you might be able to do it in your head, but I'm going to go ahead and show my work just to make sure we're all on the same page. So let's see, that would give us 5x equals -2. And then I'm going to divide both sides by 5. And so we're going to get x equals -2/5. And there we go. So my other solutions were 3 and -2/5. And so if you would have continued, using synthetic division, you would have eventually hit 3, and 3 would have worked. And so just give you a little extra practice, I'll show you that over here on the side. So if you had 5, -13, -6, because that's what we had left behind up here, right? So you could just continue it, and you'll see that if I used a 3, it'll work. 5 times 3 is 15. 15 plus negative 13 is 2. 2 times 3 is 6. That adds up to 0. And then what's really nice is then when you put your x's back where they belong, you would only have 5x plus 2, and you could set that equal to 0 and solve it to get the negative 2/5. So you could have done it that way also, but as I mentioned before, sometimes you have to do the quadratic formula. Now, as I've told y'all in class, if what you see on the review is what you can expect on the test. So if we don't have an example like that on the review, you won't have to worry about that. But just something that you definitely ran into on your homework though. Okay, so I'm going to go ahead and end this video here and pick up on the next part.